In part 7 of section 4, we'll be looking at multiple transformations, and all the parts up to this point in the section have been an expose of the individual transformations that we've studied. But more often than not, your equations are going to show multiple transformations within, so it's important that we understand how to work within that context. So example 4.11 says we need to identify two things. Number one, the equation of the parent function, and number two, we also need to identify all the transformations for each equation given. So I want us to look at part A. We have h of x there, and h of x is equal to, and then when I look to the right of the equal sign, I can see there's an x, there's also a +2, there's a -2, there's a cube root symbol, and there's also a multiplier of 1/2. So a lot of stuff going on here within this particular equation. So I want to give us a little better understanding of how to break that down and analyze what's there. Let me jump to another slide, a blank slide here, and when we start talking about transformations, we can effectively take all the transformations and we can put them into three categories. The first category being shifts. Second category are the reflections. And the third category is going to be the stretching and shrinking. So it's good that you know these different types of transformations, but just knowing the transformation is not enough. You also have to understand how it's represented algebraically. Algebraically meaning, how does it look in the equation? So when we were talking about shifts at the beginning of this section, we were talking about either adding or subtracting a real number to the equation, and that's how we were able to get shifts. Reflections and stretching and shrinking. These were created by multipliers. So in other words, the multiplication operation is what creates these two classes. So when we start looking at our equations, we want to be looking for anything that's an adding or subtracting or some kind of multiplier. So let me go back to the first slide again, and let's look at h of x. And what I want to do is I want to strip away any of the operations that are going to be qualified as a transformation. So for example, +2, I'm going to cancel that out. -2, I'm going to cancel that. I'm stripping it away. I'm not canceling. I shouldn't say the word cancel. I'm stripping it away for the moment. And then 1/2, I'm going to take that out for a moment. And what I'm left with is just the cube root of x. That's your parent function. So I'm going to abbreviate that PF, and I'll say f of x equals the cube root of x. For listing the transformations, we need to be thinking about what do each one of these, either multiplier or addition or subtraction, end up doing for us. So let me go back to that slide that we were just at. And on this slide, I want to talk a little bit more about the transformations and the importance of the transformations. We should all be familiar with the order of operations, and in the order of operations world, we should all understand that the multiplication is going to be be the word high priority. And adding and subtracting would be a low priority operation. So that means that our transformations also have a high priority and a low priority. If you don't perform transformations in the correct order, you will not get the correct picture, just like if you don't perform the operations in an equation in the correct order, you will not always get the correct numerical value. So it's important that we see the connection there between the algebra and the geometry. So every time I see a shift, that will always be the lowest priority. It'll be the very last thing that I list on my transformations list. Going back to that first slide again, and there are two shifts here. There's the +2, and there's also this -2. The +2 and -2 can be both written down at the same time. We're going to have a shift to the left by 2 and down by 2 as well. That's coming from the +2 and the -2. Then we also have the 1/2. Now the 1/2 multiplier needs to be recognized as multiplying the parent function, the cube root. So that's what tells me that this is going to be a vertical stretch or shrink versus being a horizontal stretch or shrink. So once I know that it's vertical, then I can go back and look at my definition and I can see, oh, well, 1/2 would be less than 1, which means that I must be experiencing a vertical shrink by 1/2. Let's do the same thing for part B, g of x, and we want to start stripping away all of the multipliers and adding and subtracting, so that -2 is going to go away, -3, and the -2. And if you do that, all you're left with is the absolute value of x. So our parent function, f of x equals the absolute value of x. And for the transformations, I'm going to list these in 3 steps this time. So let me bring them back. Lowest priority is always going to be the shifting. So there is 2 shifts. Again, I'll put them together at the very bottom, just like I did on part A. There's going to be a shift to the right by 3, as well as down by 2. So that really only leaves one other number to look at, and that's this -2. So thinking about what we did with multipliers, I would think about saying let A be equal to that multiplier of -2, and then I have to look at the absolute value of A, which is going to be +2, and that's the value that I want to look at my definition with. 2 is going to be greater than 1, and because of the placement of this multiplier, it is multiplying to the absolute value, then that means that it's going to be vertical. So I know that I'm going to have a vertical stretch or shrink, and the definition would say that this particular multiplier would give me a vertical stretch. Vertical stretch by 2. But I still have one step left to write down. We used the absolute value of A to determine the vertical stretch, but we can't just completely neglect the fact that there is a negative there, because remember, -2 is equivalent to saying -1 times 2. Well, anytime you have a -1 multiplier, that means you're talking about some kind of reflection. So built into the multiplier of -2 is a multiplier of -1. So there is going to be a reflection, and there is only 2 types of reflection that we're going to be analyzing, and this one is a reflection over the x-axis. Let's try part C. Part C, we have g of x, and I want to strip away all of the multipliers and additions and subtractions. So there's a multiplier of -1, multiplier of 3, and an addition of 1. So once I take those away, I can see that I have a squaring function. So I'll write the equation f of x equals x squared. And let me bring back all those multipliers and the +1. We are going to list these transformations in 3 steps. Lowest priority is the shift, and there is only one shift here. There is a shift up by 1. There is a -1 multiplier. That is going to give me a reflection over the x-axis, just like it did on part B. And then there is also a multiplier of 3. Now that multiplier of 3 is directly multiplying with the x. That tells me that this is going to be a horizontal stretch or shrink. So once you look at the definition, you can see that this is to be interpreted as a horizontal shrink. And the horizontal shrink will always use the reciprocal of your multiplier. So it's going to be a horizontal shrink by 1/3. That's the reciprocal of 3. So there's our transformation list. And we'll do one more, part D, h of x. If I take away the -1 multiplier, take away the subtraction of 4, all I have here is a x to the 4th. That's going to be a quartic function. So my parent function will be f of x equals x to the 4. And only 2 steps for the transformation list here. And let me bring them back. First one is the reflection. Again, it's a reflection over the x-axis. And then number 2, we would have a shift. And this will be a shift to the right by 4. And notice that we didn't do any graphing. All we were doing at this point was just understanding how the multiple transformations looks algebraically. And if we can make this list, then we can take the list and we can very easily use that in the graphing process. So that's where all this is going to be leading to.